So, welcome to our Academy training, Individual Standards, how to create your own profiles. Before we start, I want to introduce myself. My name is Birgit Wippler. I'm in the Department of Service and Consulting, and I'm within GMG since 2007. That's a long time. Before I studied printing and media technology in Stuttgart at the Media University. I started at GMG in the technical development department, and then I led the application technology department. And yes, I would say I'm a specialist for profile creation in Profile Editor and OpenColor. And yeah, so it's my topic today. Let's have a short look to the agenda and our topics for the next 30 minutes. First, we will talk about what is a print characterization in general. We will talk about ISO, PSO standards, industry standards versus custom fingerprints. And we will take a look how to make an own fingerprint, test form creation, fingerprint analysis of the print, measuring the test charts, and optimization and finalization of the measurements and the data. And we will get a short overview about different profile types that use our characterization data. Let's start with the question, what exactly is a print characterization? I think this definition matches quite well. A print characterization is the representation of the entire print production process, including all parameters and variations, reduced to the color result. This means all parameters that play a role during printing have to be taken into account, including upstream processes like screening, rib settings, CTP, the TVI curve, inks with defined printing properties, as well as the definition of target values for the primaries and the substrates. Also, the parameters of the printing machine itself play an important role, like the printing speed, etc. If one parameter of the process is changed, like the screening, rib compensation curve, and so on, we talk about another characterization. In which case, we can work with an industry standard, like the ISO or PSO standards, or like Graycole and SWAP in the US, or the PSR profiles in gravure printing, and in which case do we need a custom characterization. You can use an industry standard if you print within the tolerances that are defined in the standard. If you print, e.g., like defined in ISO 12647-2 for offset printing, and all parameters like TVI, solids, paper tint, and paper class correspond to the standard, then you can use an industry standard. An adaptation of an industry standard is possible if all parameters match the standard, but only one parameter, for example, the paper tint, differs. In this case, an adaptation of the characterization with the GMG paper adaptation tool would be possible. This tool adapts the paper tint and the gray axis and keeps the general characteristic of the printing process. The creation of a custom standard is recommended and useful if no industry standard exists for the printing process. For example, if a completely different paper type is used with a special surface or a colored paper tint, like the Financial Times paper, or it's mostly needed in the packaging where you work with many different substrates and a lot of spot colors. So let's take a look to the steps for the creation of a custom standard. The first step would be the definition of all parameters, like the printing machine, the paper, and the inks. The second step would be the test form creation with images, with test charts and further test elements in production size. Then we would make the fingerprint and control all parameters. We have to select some sheets for the evaluation. Then we make the measurements of the test charts, the evaluation, and the optimization of the measurements, and we finalize our characterization data. And then we can use the characterization data for profile creation and for a recheck with the proofing profile. So we compare our proofing profile with the images and the control items on our test form. And optional, we can recheck, correct, and fine-tune our characterization after further production print runs. So if you see after some print runs, okay, our TVI in magenta is a bit lower, you would have the possibility to compare it again and to modify your characterization. The test form plays a very important role as it delivers a lot of important information about the print run and enables a quick check if the print run is really successful or not. So let's put some elements on our test form in different groups. We have some process-related elements like a print control strip for ink control during the print run. We have some color strips on the top. We have some register marks and so on. Furthermore, we have some technical elements like wedges with gradations, circles, color gradients, like a Siemens star or positive negative type to check the resolution on your substrate. We have some images on our test form, gray images, black and white images, some skin tone images, and primary, secondary, and tertiary images. You can take either images from internationally known image libraries, like the Roman 16 from the BVDM, that's the German Association for Print and Media, or you can take images from the Altona Test Suite, or the Visual Print Reference images from Switzerland, from the UCRA. The advantage is that the images can be ordered by everyone and that they are very popular. That means many of us worked with them already. That makes it easier to check the plausibility in one view. Or you can take your own images and motifs from your customer, from their production. These images are mostly well known, as you know the critical issues with these pictures quite well. And last but not least, we have some test charts on our test form. We have different layouts for different measurement devices. They need different patch sizes, different marks or color bars. And you can either use standard charts like the ECI 2002 or the IT 874, or you can use custom charts in your own size and layout. Maybe you have less space on your test form and you need a smaller test chart. You can create it in OpenColor, for example. And there you also can create test charts that include overprinting spot colors. And we have mostly some further elements for measurements. For a quick measurement evaluation, I would recommend to use a mini strip with a subset of patches. Or you can use, for example, the Graycon strip, or build yourself a Graycon strip for the evaluation of the gray balance. Here we see as example a test form that was used for the creation of the FOCRA 51 and FOCRA 52 characterization data. We have a test chart with a high amount of patches, more than the 8874. This was a special plus version. We have below some gray images, 4 gray images that react immediately to color shifts and show variations in the color zones that affect also our test chart. So that's a quick check of color shifts. On the right side, we have some pictures with saturated colors, primaries, secondaries, and tertiaries with different skin tones. And we have additionally between the pictures some color patches that contain the colors from the images next to the image. We have a mini strip with a reduced amount of patches for a fast measurement, placed several times on the test chart, here on the middle, on the right. And we have a gray 4-color background over the whole test form that enables a fast visual check of variations in color zones and helps also to get a homogeneous ink uptake. That's often used in offset printing. So we have different requirements for the test chart and the test form depending on the printing process also. For example, in offset we have to fight with the color zones. In gravure printing you have the ribbon differences on the engraved cylinders. In digital printing we have mostly to fight with inhomogeneities in toner-based systems. So there's a question where to place the test chart. And we have a low printing resolution mostly in the fast inkjet systems. So we need, for example, a bigger patch size with multiple measurements per patches or something like this. So it depends on the printing process what is needed for your test form. So let's go to the print run. The fingerprint reflects an average print run in normal production environment. The aim is to achieve an image of the production conditions, means same screening and rib settings, same plates, same inks, same TVI, and same or similar production speed and paper size. We recommend to terminate the fingerprint between 2 production jobs. It should not be the goal to take the best out of your machine on the day of the fingerprint. It should show an average of the current production process. But it shouldn't contain any errors like ghosting, scumming, misregistration, shift in color zones, or wrinkling in the roll or something like this. So you need a good print run, but it should match your normal production conditions. So it is equally important to define and document all single parameters in all process steps before you go to the print run. So just check which parts can be defined by yourself and which parts are influenced by partners or the customer and should be defined and checked with them previously. Be well prepared for the print run, as you won't have any time during the machine is running. And here we go. During the print run, you should pull sheets in regular intervals for quick evaluation, visually and by measurement. You should define an OK sheet that is closest to the predefined target values for primaries and TVI. And you should mark the palette and the roll every 100 sheets during the complete print run. Try to determine all variations. Try to gather the protocol from the machine or something like this. This helps a lot to get an idea afterwards what happened during print. And then we need some sheets for measurement. How many sheets should we pull out now? The first one, or one from the middle, is one sheet enough? The question is, how many sheets do we need to extrapolate from them to the average of our print run? One single measurement is not enough due to variations over the print run, but which samples represent the total quality, and should we exclude some samples? Maybe we need some statistic here, but statistic tells us to measure a lot, really a lot of test charts. Depending on the calculation method, 10% of the total amount. If you print 10,000 sheets, that's a lot. That's not realistic. So we recommend the following. Pull sheets from 3, better 5 different parts of your print run after the defined OK sheet, and pull out 3 consecutive sheets. One sheet for the measurement, one sheet as a backup, and one sheet for archiving. And archive the sheets directly after the print, protected from the light. And all sheets should be checked visually and should be labeled immediately, that you know which sheet was pulled out, in which time, and so on. The next step is to measure test charts and other elements to evaluate and to optimize the measurements. Before we start with the measurement, you should take care about your measurement device, the settings and conditions. Is the measurement device maintained and recertificated from the manufacturer on a regular basis? Is the white tile cleaned? Check if the measurement device and the white tile match together. That's important if you have several devices from the same type. Then you should use a correct white backing according to 12647-7, e.g., for example, 2 sheets of GMG CMIMAT 250 proofing paper. And you should check the correct positioning of the test chart, especially if you use an XY table like the I1IO. Then is the question, if you have several measurement devices available from one measuring device type, then you should think about repeating the measurements with other devices to average the differences between the measurement devices from one type. And you should document all parameters related to the measurement, the serial number of the device, which measurement software was used, in which version number, what backing was used, and so on. Last but not least, save the measurements with a reasonable naming as LAB and spectral values. Also, if you use only LAB for profiling in the moment, it might be possible that you will need spectral values in the future or for the usage in OpenColor. So after the measurement is done, we start with the evaluation. Depending on the software that was used, you have different possibilities in the analysis and optimization of the measured data. Generally, you should check the following criteria. Are the measured values plausible? Maybe something went wrong during the measurements. Do you have very high delta E's? Check the corner colors. This means the solids and secondaries. Did they match the targets? Check the smoothness of the single ink wedges. Do you have steps between the tonal values, breaks in gradation? And check the correlation to the process. for example, the TVI. In the next step, you could do a comparison of several measurements and check the correlation to the color variations during the print run. So maybe you know during the print run the magenta TVI went down some percent, or you had some variations in density, so you should check the solids and check if you see these changes during the print run on your test charts and on your measurements. What about the averaging of several measurements? Can we average? Yes, but you should take a look if the measurement represents the average. If there are strong deviations due to problems during print run, you cannot use these measurements. But if all measurements are within the defined tolerances, an average helps to minimize smaller variations. So one tool for analyzing your data is the GMG Gamut Viewer that is part of the GMG Profile Editor. The Gamut Viewer enables to show the Gamut as 3D object. The grid shows the outer shell of the Gamut and enables to analyze the homogeneity and the linearity of the print result. This is a very linear Gamut here in our screenshot, but normally after a print run you get some grids that are not parallel and show some irregularities. That is normal. You can compare several measurements in parallel. You can load here several measurements, and you can check how good they match together in homogeneity and in the primaries and secondary colors. You also can compare two measurements in a delta E view with some little arrows that show a color shift. And you have the possibility to show the TVI, but it's calculated in LAB and not over the density in this view. Another tool is the GMG Profile Editor that is part of ColorProof or Color Server. That's our tool for profile creation and editing on LAB basis in 4C for a CMYK color space. It shows the complete grid of the color space with all patches and all measured values, and you can use it to compare two measurements, and you get the delta E and the delta LAB for each patch. So you can check also the paper tint, the primaries, secondaries, and the deviation of the gray balance. You can also average several measurements by multi-select during the import, and you can smooth your target values and remove outliers. But there you have also to be careful. It makes no sense to smooth your target values too strong if you are not representing your printing process anymore. You also can do color corrections on the corner colors, for example. And finally, you can export your characterization data from here. A further possibility to optimize your measurements is within GMG OpenColor. That's a profiling tool based on spectral data for CMYK and spot color usage. And here you can correct the solids to the target values. You can adapt TVI curves manually by editing and adding and moving single steps on the TVI. You can make relative corrections over the whole curve, and you can load existing TVI curves to another color as target TVI. All corrections are done on a spectral basis. This means they affect the complete color space. So how can a final characterization look like? We have an example here from FOCRA 51 TXT. You can export your own TXT file from Profile Editor and modify it in a normal text editor like Notepad. In OpenColor, the final characterization can be used within the OpenColor project for profile creation. So let's add some information. In the first part, you see a header with additional information about the owner of the characterization, the creation date, the printing process, printing machine, substrate, and you also can add some comments. And in the second part, you see the measurement values with the structure of the sample ID, the CMYK value, and the LAB values. Optional, you also can save XYZ values or spectral information in your characterization. It's important to ensure traceability, so you should structure the complete project with an understandable folder structure and file naming. This means we mostly have to clean up a bit afterwards. I recommend the description of all steps in a separate document, or at least in some README text files together with some screenshots. So now we have finalized our characterization and can use it for profiling. We have to differentiate between different profile types. Let me give you a short overview. For profile creation, we can use our profiling tools. Oh, that was too fast. One step back. Yes, we have conversion profiles for the usage in Color Server and Color Plugin. This means we can create RGB to CMYK profiles from an RGB color space like ECRI RGB to your custom characterization or to a multicolor characterization, or from another CMYK color space like ISO-coated V2 to your custom characterization. And also, one type of conversion profiles are the profiles that optimize your printing data. This means they just reseparate the printing data with another gray balance or with an ink optimization for ink saving. But this would be a further step. Mostly you need the RGB to CMYK profile for your characterization, or a CMYK to CMYK profile for the data creation. And you mostly need a proof profile for the usage in color proof. You can create this one with Profile Editor for CMYK, or in OpenColor for CMYK or multicolor profiles with spot colors. I think it's not possible to go through the complete profile creation step by step in the software now. Therefore, such a 30 minutes webinar is not the right tool. Therefore, we offer separate one-day trainings in our academy. So that's it so far regarding the profile creation. Are there any questions regarding the test form, the print run, the measurements and evaluation of the measurement data. So, no questions so far. Then I would like to recommend some upcoming trainings in the Academy. We have one interesting training on the 15th November. It's the same topic like we had today, but with many tips and tricks for the practical realization. So we build a test form together from the beginning. We will measure some test charts and evaluate the differences between some measurements, and we also will create some proofing profiles in the last step. It's a complete one-day course here in Tübingen in the GMG headquarters in English language. You can find registration and further information on our Academy homepage. We have an interesting two-day workshop in English language also, in close collaboration with the DFTA Flexo Center on the Media University in Stuttgart. So we will make an own fingerprint in Flexo print. The first day we will talk about the basics of color management, and create some print-ready data. And on the second day we will make the pre-press and the print on the Media University in Stuttgart. And we will have some free webinars this year. I think 1 or 2 further webinars. You will get the newsletter and with the registration links. And we will have some custom trainings available for individual trainings, where we can talk exactly about your questions. Okay, I see now there is a question about OpenColor and Profile Editor. Just let me read it. Okay, the question is if OpenColor and Profile Editor can create ICC profiles or only MX profiles. That's a proprietary file format from GMG. So if these profiles can be used in Photoshop directly, no, that's not possible. So what we can export in Profile Editor or in OpenColor are profiles that can be used with our GMG Color plugin in Photoshop, but we cannot export an complete device link ICC profile. Okay, and there's another question. One moment. The question is if the screening angles that are used in the print run, in the print trail, if they influence the color. Yes, definitely. If you use different screening angles, then you have a different characterization. So if you have one time 0, 15, 45 and 75 degrees, and the next time 6.5, 15 and so on, you would have different print results in overprint, and this would affect your color result. So we would talk about different characterizations. Okay. Any further questions? There's one question regarding the measurement conditions. Is it better to make measurements with a UV filter or not? There had been some changes in the last years regarding the ISO standard for measurement. Now we have a measurement condition that is called M1 that corresponds nearly or is very close to the defined D50. So I would recommend to take this M1 condition. The UV filter condition would correspond in this new ISO standard to M2, and the no filter condition would be the M0 condition. The M1 filter condition is the one that should be used for all measurements, as it corresponds best to our visual result on the light booth under D50 light. So it takes into account the OBAs in your paper, and with the M1 measurement, the complete system of printing on a substrate with OBAs or not, measurement and viewing under D50 norm light makes sense now. We also have an training and maybe also a webinar on our homepage available for the new ISO standards and the changes in the ISO standards over the last years in the ISO standard for offset, but also for measurement and for viewing, and maybe this would be interesting for you. Okay, if there are no further questions, I would like, yes, to show you our GMG contacts, info@GMG-Color, academy@GMG-Color, support@GMG-Color. There you can also register for our technical newsletter. And I would like to thank you for listening, and I hope we can see or hear us again in the GMG Academy. Thanks and have a nice afternoon. Bye-bye.